Before going into the details of this project, first I would like to give you some introduction about haptics. Haptics is a technology which enables computers to provide a force feedback. And this technology is mostly used in surgical robotics. So as it is very critical for a surgeon to not only visualize but also to feel the reaction forces provided by the subject. So as you can see in this demo, an operator is interacting with the spinal vertebrate, and he is also not only visualizing but he is also able to feel the reaction forces provided by interaction. So we at Islamic University of Science and Technology wanted to take this technology from the field of surgical robotics to the field of education, where it can be used to teach students concepts of physics like friction, rotational motion, viscosity, stiffness, and much more. As you can see, our haptic device is capable of manipulating the motion of robot, and it's also capable of providing haptic feedback. That is, when two of the links collided, user could actually feel the collision on this device. So coming to the development part of this device, we started from a 3D model and we wanted it to be 3D printed, so keeping that thing in mind, we designed it. And this here is the electronics of this device, which was mounted on a development board. And this here is the circuit of this PCB. And finally we come to the PCB designing. And this here is the finished electronic board. And back to the CAD model. And this here is a 3D printing process of a particular part. And finally a software was developed for a computer to which this device was to be connected. And this is the GUI or graphical user interface. So in this example, as you can see, a pendulum is here, and the dynamic changes that could occur in the pendulum can be visualized and also can be feel with the link of this device. And this here is the famous example of spring and damper. So this is also provided with two sliders, one for friction and one for spring coefficient. So once the frictional coefficient is increased, you can feel actually the friction provided by the wall and this piston. Now the spring coefficient is increased, you can feel the reaction forces provided by a spring. And once the spring coefficient is decreased, you can accordingly feel lower reaction forces. And finally, we also got a chance of presenting this work at All India Robotic Conference 2017. And thanks for watching.